everybody and welcome to another edition of our British Science Week mini experiments. So I've got the wonderful Emma here with me today. Thank you for joining me, Emma. And the reason why everything's a little bit dark today is because we are doing experiments with light. So we're thinking about optical illusions and how primary colours in light work and things like that. So we've had a bit of a play about this morning, haven't we, Emma? Yeah. It's taken us a while to work out how to do things, so hopefully this will work. Are you ready to start?
Well, me and Mike found out to get cyan, which was at least quite exciting when we got to that point.
Yeah, so Mike helped, so thank you very much, Mike, for all your help. So what we're going to do is we're going to start with playing around with our theatre gels. So these gels, these like films of plastic. Emma holds one up. So hopefully you can see there how that's a see-through film and it's blue. And it's blue, I've got 4 colours here because the primary colours of light are different to the primary colours that we use in art with our paints and things. So if you've heard of RGB, that is the primary colours of light. Red, blue and green. So obviously if we hold these up, you guys can see the different colours, but if we put them together, you end up with black. And you can't really see, even if you only put 2 colours up together, how those mix to make the primary colours of light work. So this is because this is called subtractive colour blending in light. And it's where when you put things together, it subtracts down to black and dark. So what we need to do is use light sources, don't we, Emma? So Emma is going to do the filming for me, aren't you? So Emma's got the GoPro. If you hold this, and we're going to press record, yeah? And then hopefully what I'm going to do with this, I don't know how this is going to work. Can you see underneath? So what we thought we'd do, just to make sure that you guys could see the full effect, was to zoom right in on the gels coming through this glass plate that we've got and putting the torchlight through it again. So I'm going to start with the blue, and we had it on not the highest setting, the lowest setting, didn't we? So we've got the blue light there, and hopefully it's not going to slide about. And then we're going to add in our green, and hopefully putting them together you can see the spot of cyan where the green mixes with the blue. And then finally we've got our red. Now this is a stronger colour. I'm just going to make sure that I've got this on the lowest setting because I don't want to overpower anything. Yep. And then we're going to add our red in, and then hopefully you'll be able to see in the centre there where it becomes white. So the red and the blue together make magenta. The blue and the green together make cyan. And then the red and the green together make yellow. And then all together, because it's a additive process, mixing light, we end up with white. And that is how the theory of prime colours in light come together. So the next thing we were going to do is, after working with our gels, show you guys some optical illusions and some light going through prisms. So I don't know if did we want to shine them down through on the table, Mark?
Try both.
So we're going to put our prisms, and hopefully this one isn't going to roll around too much. We put our prisms on our glass, and we're going to get one of our torches. We want it quite bright. That is really bright. Sorry, guys. And we're hopefully going to be able to see some light splitting. Now, I don't know if you can see down here, the colours coming out of the prism, can you see on the paper there, Emma?
It's like a line.
Yeah, it's actually splitting the colours as the light goes through.
Yes.
It's rather difficult to see that. Definitely getting rainbows in front of the camera.
The other side of the table. Not anymore, but before you did.
So it's basically a case of like moving the torch around and trying to get it to do the rainbow effect. See, I can see a rainbow here.
There's something shooting off somewhere.
Yeah.
Yeah, like a rainbows.
Where? Oh, yes, there. Can you see on the screen, Emma?
It's on Emma as well.
And on you. So that is the light being split and refracted by the glass. And because the wavelengths of light, all the different colours, are different lengths in their waves, it splits the light into different colours, which is really cool, isn't it? Turn that really bright torch off, and I don't want to blind anybody. And the last thing we were going to show you guys, unless you want to do the laser thing. You want to quickly do the laser thing? So, I don't know whether we need to do this on the table or what, but if you point that here, Emma. Woo! I don't know if it shows up, but
It's like a green.
so the green line is being refracted. Ah, that works better. So when I point the laser into the prism refracts the light and splits it and sends it shooting off into all different directions. If you catch the edge, you can get a really nice effect. It's almost circular.
Cool.
It's great, isn't it? And depending on where you point it, you can get different circles moving out. I don't know what this one will do. Whether you can see it bouncing through and out. Ooh, you okay, Emma? So yeah, the circular one will kind of collect the light, I would imagine. Oh, it spins it round.
There's a line going that way.
Isn't that great fun? So that's the way the glass is refracting the light. I have no idea what this one will do. If I point it at a corner or a side. See, from the top, it looks like it's just going straight through, doesn't it? But when we put it to the corner, it's dazzling. It's a bit like a mirror ball, isn't it?
That in the mouth.
Yeah, so it's a bit like going to the disco. So that's how light refracts. So the last thing we've got to do, I don't know if you want to spin them or you want me to.
Probably easier if you spin it.
I'll move them out of the way. So we're going to go top down. I'm just going to alter this for Emma. And we've got these little optical illusion spinning tops here. And what happens, we're doing this with the GoPro especially for you guys, is that when you spin the disc, you'll get this visual effect that you'll see with your own eyes, which kind of smooths the patterns out. But because of the frame rate on the GoPro, you end up with this really weird effect. So we'll give it a spin. So hopefully, for you guys on the main camera, you've got this kind of smoothing out effect. But when you see the top-down view from the GoPro, woo, span it off. You'll have this kind of flickering interference effect. And that's all.
Looks like it's starting about.
Yeah, so it looks like the concentric circles are going in opposite directions, doesn't it? Which is really good fun. And that's all about how quickly your eye processes the things that it's seeing compared to how quickly the camera takes tiny little microsecond pictures to make up a video. And we've got another disc that does a very similar thing, but this one's in black and white. So it'll look like it's going one direction for some of it, and then I think it looks like it's going the other direction in the other one. I really am not very good with spinning tops. So yeah, this looks very smooth to you guys on the main camera, but on the GoPro, it looks like it's gone backwards again, hasn't it?
Going that way.
It looks like it's going that way. It looks like it's going counterclockwise, even though the spinning top is spinning clockwise. And that's all to do with the way that our brain connects to our eyes in a different way to the camera sees the image as well. Okay guys, Emma and I have stepped outside so that we can show you some other effects with our wonderful prisms that we've been playing with the lasers and the torches. So what I'm going to do is I'm going to put the focus all on Emma, and then I'm going to put the prisms in front of the camera lens so you guys can see the effects. So we're outside, as I was saying, and we are playing with the prisms to see the effect that they have when we hold them between Emma and the lens. So hopefully you can see this wonderful sphere turns Emma and the whole world upside down. So I'm going to hand that to my wonderful assistant behind me. Then I'm going to take the pyramid, and as you can see, it reflects and refracts. That's really hard to hold. So even though it's pointed at Emma, it's very difficult to see her. Can only just maybe get it there, and that's bouncing off two sides. And if we do that way, we can see the scenery all around. What's in my other pocket? So this one, we've got the triangular kind of one. So if we look straight down it, obviously we get the full effect of Emma, but if we look from the side, we get things reflected twice over. So I've got to point at the sky basically to be able to see Emma. And then last but not least, if I rummage in my third pocket, we've got our cube. So again, if we look straight through the cube, we have Emma full effect. But if we look from the corner, we see she's kind of split. And then we can see the scenery all around her. So you can see left and right, up and down the path. Brilliant, thank you very much.
We're back in from the cold.
It was rather cold out there, wasn't it, Emma? But good fun playing with the prisms. Yeah?
It'd probably be interesting to see actually.
Yeah, because you couldn't see the effect being on the other side of the camera, could you?
I could see me in
yeah.
the sphere. Like, but I look that way.
Yeah, so everything turns upside down. It's brilliant, isn't it?
But that's the only one I could actually see what was going on.
Right. Well, we'll look forward to seeing all of our British science videos coming up next week. I would like to say thank you very much to Emma. And we will say goodbye for now. Bye, guys.
Bye.